Direct Connection is made by MPT to serve all of our diverse communities and is made possible by the generous support of our members. Thank you. Live from Maryland Public Television, this is Direct Connection with Jeff Salkin.
Hi, everybody. Thanks for tuning in for Direct Connection. Imagine a world with more liquid water than we have here on planet Earth. It's not in science fiction or some far-flung galaxy, right here in our own solar system, and it could have implications for finding life outside of our planet. The detective work on this is being done at the Hubble Telescope headquarters in Baltimore. Joining us tonight, William Sparks of the Space Telescope Science Institute. Dr. Sparks, thank you for being with us.
My pleasure. Thanks for the interest.
I should note on our science theme tonight, we're keeping tabs on a rocket launch at Wallops Island, scheduled for about 10 minutes from now. If that goes off, we'll bring that to you live. But Dr. Sparks, first, to take everybody back to the grade school knowledge of the solar system, Jupiter is the biggest planet, and it has more than one moon. It has a bunch of moons.
It's got lots of moons, yeah. There are 4 major moons of Jupiter, the Galilean satellites, which were discovered by Galileo
400 years ago, right. And he didn't have a Hubble Space Telescope.
No, he didn't, but he did quite well.
Now, when you look at a picture of Europa, one of the major moons, what you see is a desolate place. It does not look like the first place one might go looking for life in our solar system.
That's right. Europa is so far from the sun, it's extremely cold. But it's deceptive because Europa has more water associated with it than the Earth does in its own oceans. There's probably twice as much water in the oceans of Europa that there is in the oceans of the Earth. But it's so far from the sun and it's so cold that global ocean, it's a true water world, but that global ocean is covered in a crust of ice. And we don't know how thick the ice is, but it could be very thick.
So when you look at the common picture of what Europa looks like from, I don't know if this is a telescope or a flyby, you see this desolate place and you see lines on it. Are those a clue as to what's under the surface?
They're part of the clue, yes. The surface of Europa is geologically very young. There's no craters there, really. There's a couple, there's 1 or 2. But the surface is very smooth, but there's evidence in those lines of tectonic activity, of the ice moving around. And it's one of the lines of evidence that, in fact, Europa is an ocean world. And, of course, we know that the material is ice, and that's another clue.
There's an artist's conception of what a cross-section of the planet might look like. And I believe, is there a solid core down there somewhere?
Yes, there is. The ocean's thought to be about 100 kilometers deep, and that's pretty deep. It's about 10 times the depth of the Earth's oceans.
And that's the dark blue on that image might be the water?
Yes, and above that, the ice, and the thing that we're interested in are those cracks and the related phenomena of whether or not there are actually plumes of water erupting from the surface of Europa, which is what this is about.
And that's the discovery that was announced in the last week or so, is an image that appears to show, and it's highly pixelated, but what you perceive as evidence of, it's almost like an Old Faithful type geyser shooting some of this water out into space.
Yep, that's basically the picture that we're looking at. If indeed these are confirmed as geysers, they're about maybe 10 times bigger than Old Faithful. So they're big, but they're not outrageously large.
It's hard to envision such a place where the ocean, I suppose we have polar ice caps, and there may be water under that. And is that a way to think about it?
It is, and it kind of highlights one of the problems, because normally ice just sits happily on top of water, and the water doesn't erupt through the surface of the ice. And so one of the challenges in this work is to try and understand what it is that forces the water through the ice and into space.
You have an interest in the possibility of life existing outside of the planet Earth. Is this a promising place to go look for it?
It absolutely is. That's the main reason why the plumes of Europa and the possible geysers are interesting, because if they communicate with the ocean below, and they may very well, that means that we can access the material of the oceans of Europa without having to drill through miles and miles of ice. We can start to study the stuff that's been sprayed out through the geysers, and it's falling back onto the surface. And we can interrogate that and see if we can find evidence that there was life in the oceans of Europa, if there was.
Is it true that on Earth all of the life we know about uses water in some form, but we have life in the most unlikely places, deep in the ocean where there's no light, there's no oxygen. There are these geothermal vents with all sorts of sulfurous compounds coming out, and yet something lives there.
That's right. As far as we know, every single living organism on the planet Earth shares a common ancestry and requires water, nutrients, and energy to survive. Europa has all of those. It has the water, it has the nutrients, and it has energy sources. And so it's one of the most exciting places beyond the Earth where we can go and look for life.
Let me remind our viewers, if you have a question about the work of Hubble or what has been possibly found in orbit around Jupiter, give us a call. We'll have the number up on the screen. You could also tweet your questions. The Twitter address is @MPT News. So Jupiter, quite far from the sun. The sunlight isn't going to melt any of the ice, even on the surface. What makes it a liquid down below?
The basic energy source that's pumping heat into the ocean of Europa and keeping it a liquid are the tides. And as Europa moves around Jupiter, its distance from Jupiter changes ever so slightly. And as the distance changes, the tides change. And so there's a constant squishing and stretching of Europa. You see it more in extreme if you look the next satellite in with Io, where there are amazing sulfur volcanoes, and that moon is really hot.
Probably less promising place to go look for life than Europa, you're saying?
Yeah, no water there. At least if there is, it's hiding.
Let's take a phone call. Prince George's County, this is Mark. Thank you for the call. Go ahead.
Yes, hi, sir. Thank you so much for your briefing. I'm trying to find out what your thoughts are about where the water actually came from here on Earth and Europa as well.
Great question. Thank you for the call. Is water in the universe common, uncommon?
It's common. It's using two of the most common elements. Obviously, hydrogen is the most common. There are various discussions as to where the water on Earth comes from. Comet delivery from the outer solar system is one possibility. But I think the general consensus in both cases is that it's primordial. It was around at the start of the solar system, when the solar system first formed. And Europa is much further out, and so there's less heating by the sun or the young sun, and so the water and other volatiles can stick around more easily than in the inner solar system.
Let's take a call from Washington County. This is Ron. Ron, thank you for the call. Go ahead.
Good evening, sir. It's been reported that we will be traveling to Mars in the next few years. My question is, how are we going to, in a few years up, time there and back, how are we going to manage the oxygen needs for these people? Thank you.
Thank you very much. Not your specialty, but if you want to weigh in.
I think it's going to be extremely challenging to set up a human habitat on the surface of Mars in the near future. There's a lot of enthusiasm to do it in certain constituencies, but it really is extremely difficult. There are things we can do in the meanwhile to lay the groundwork, such as building more effective space stations and constructing things in space, but to just go there would be difficult. To answer the specific question, I believe the general idea is to make the oxygen from the rocks when you get there.
And an even more challenging mission, even for an unmanned vehicle, would be Jupiter and Europa.
Yes, and there is an unmanned mission to Europa that's just gone into development last year. And that's one of the exciting topics for the future with Europa. That mission has been selected, designed, the instruments have been chosen, and now they're doing the detailed work of figuring out exactly how it's going to be built, who's going to build it, and what it's really going to cost and look like.
Do you hope to influence that at all?
Well, I think the presence of plumes on Europa will probably influence it somewhat. The instruments that are going to fly have already been chosen, and the design of those instruments is to probe not whether or not Europa is inhabited, but to probe the habitability of Europa. So it'll determine the depth of the ocean, the thickness of the ice shell, the composition of the material on the surface, and things like that. And so overall, it'll lead us to a much better understanding of the Europa mission.
Now, these geysers, I compared it to Old Faithful before, but what I read was there were 10 measurements taken, or 10 observations, and the geyser was only seen on maybe half.
It was less than half. It was 3. Our observations were not the first, though, and the first observations were by an independent group a year or so before our observations, and they observed Europa in a completely different way. They looked for the dissociation products of water, hydrogen and oxygen gases, and that's the evidence that they found. We looked more directly just for evidence of water vapor, and we found on 3 occasions out of 10 that there was evidence for something off the edge of Europa.
And water vapor is hard to see just in a room like this. You're looking across a vast expanse of space. How do you see it?
The way we see it is by going into the far ultraviolet. If we go into the far ultraviolet, ice becomes very dark. The cross sections of the molecules that we're looking for become large. In other words, they extinguish and attenuate the light much more effectively than it does at visible wavelengths. And there are a couple of other advantages of going into that wavelength range as well. One is the surface of Jupiter itself is very smooth, and so we can see things more easily against the smooth background. And the other is the fineness of detail that Hubble can perceive is improved when you go to shorter wavelengths in the ultraviolet.
Let's take another phone call from Baltimore County. This is Sam. Sam, thanks for the call. Go ahead.
Yes, I don't believe you mentioned the relative size of Europa to Earth, and does that affect the water content on Europa?
Great question. Thank you very much.
Europa is significantly smaller than the Earth. In fact, it's just a little bit smaller than the Moon, our own Moon. Whether it affects the water content per se is unclear at this point. There are a lot of those icy worlds, as they're called, that appear to have oceans below the surface. Europa is the most obvious because the heating of the Moon by the tides as it goes around Jupiter melts the water, makes it visible, puts it on the surface. There are other places where the water may be under rock, and then that's much harder to see.
I'm not going to understand the answer to this, but how do you know all this? How do you figure the thickness of the ice, the amount of water with limited tools?
You use the tools that you have, obviously. The primary evidence for an ocean on Europa came with the Galileo spacecraft. And the Galileo spacecraft could measure the electrical response from its magnetometer, an instrument that measures the magnetic fields as it flew by Jupiter. And the response was from a conducting fluid, and it was exactly what was predicted. And so that tells you 2 things. It tells you there's a liquid ocean, and it tells you it's conducting, and so there's salt in the ocean. It's a true ocean.
And it would be dark, right? Would there be any light source? Certainly not that would penetrate that much ice.
The sunlight won't get through the ice. Whether there are internal sources of heat, we don't know at this point. But it'll be a dark ocean, that's for sure. And it'll be more like the really deep ocean on Earth, where perhaps there are hydrothermal systems or something like that that would provide the energy sources that you might want to find.
I know you've been with the Hubble project for 30 years. Does it bother you that you can't act more quickly on results like this? There might be a mission, it'll get there in a few years. Are there other observations that you can make in the shorter term?
One of the beauties of the Hubble is that, at least with telescopic facilities, we can react quickly, and we can make more observations with the Hubble and with other telescopes around the world. We have a little more data that we obtained subsequent to the paper that we published, so we'll be working on that in the next few months. The Hubble is still there. The Hubble can make more observations. And then there are future telescopes like James Webb, looking ahead maybe only a couple of years. The launch for the James Webb is 2018, and so that's not too far off. The mission itself will take a lot longer, though.
Let's take a pause from this discussion for a minute to update you on what's happening at Wallops Island, Virginia, on the Delmarva Peninsula, just a few miles from Maryland. That is the Antares rocket that has now been fueled. It is on internal power. The launch time was delayed from 7:40 to right about now.
9, 8, 7.
Let's listen in to NASA TV.
5, 4, 3, 2, 1. And as you can see, Cygnus lifting off on top of its Antares rocket on its mission to deliver supplies and science to the International Space Station.
DHS and CBC are nominal.
The first stage is now burning and will burn for 3 minutes and
So far,
20
looks like a clean launch, in contrast to the accident 2 years ago, where a similar unmanned vehicle exploded shortly after launch at Wallops. This is a resupply mission, again unmanned, heading for the International Space Station. 5,000 pounds of food, cargo, and experiments headed to space from the east coast of the United States, on the eastern shore of the Delmarva Peninsula at Wallops, which is seeing increased activity as attention turns to resupplying the space station. There are 2 private contractors that have the NASA contract for these supply missions. The other is SpaceX, which is currently grounded. So far, so good for NASA and the people aboard the space station. You're watching Direct Connection on MPT. We will take a quick break and continue right after this.
Election Day is November 8th. Maryland residents can register to vote through October 18th. Visit elections.maryland.gov or call 800-222-8683. Register today and vote on November 8th.
There is one stage that is the Met and Carnegie Hall. It is the Kennedy Center and a club in Austin. It is closer than any seat in the House, no matter where you call home. PBS, the great American stage that fits in every living room. Supporting your PBS station brings the arts home.
This is a box that showed you a world beyond your own. It was just a box, but the world has changed, and so have we. And now the box can be almost any size or shape. And you decide what you want to explore. Anytime, any place. Break out of the box with PBS.
Continuing now with William Sparks of the Space Telescope Science Institute, lead astronomer on the project to look at Jupiter's moon Europa, where plumes of water have been seen shooting off the planet into outer space. We think about those plumes in the context of Old Faithful, maybe goes a couple 100 feet up. This is hundreds of miles, you believe?
That's right. Between 100 and 200 kilometers. 150 miles, roughly, something like that. Astronomers aren't very precise when it comes to things like that, but this time we can measure them, and that's right. It's more like hundreds of miles than hundreds of meters.
And your dream is a fly-through where you get to sniff that a little bit?
That would be an interesting experiment to do. It's actually surprisingly difficult, though, because the spacecraft, when it reaches Europa, will be traveling at incredible speed. It'll be roughly 4 kilometers per second. And so sampling the plumes directly is going to be extremely hard. We can certainly sample the environment, but the main interest from my point of view will be to try and sample the material that's rained back down onto the surface of Europa. If that's originated from the ocean below and it's just lying there on the surface, let's take a look at that.
That would be fresh snowfall, basically.
Presumably, yes, presumably, yeah, with whatever else was in the ocean.
And the reason we're so interested in this is that your belief is this is one of the prime areas to look for life outside of planet Earth, and it's within our solar system.
Yes, that's right. So there's a lot of interest in looking for life elsewhere in the universe at the present time. Thousands of planets have been discovered orbiting stars around orbiting stars other than the Sun, but it's very difficult to observe and characterize the planets of those exoplanets, as we call them, and to try and understand if they have life on them. And in some sense, you can view this as a little bit of a pathfinder. Do our methods work? Can we measure the presence of life? And of course, we don't know that there is life on Europa, but if we could find it there, that would be incredibly exciting.
Let's take another phone call. This is Prince William County, Virginia. Baharam, thank you for the call. Go ahead.
Yes. Well, my question is simple. If we land on Europa or other planets and we find minerals, who will own the properties? Is Europa going to belong to United Nations, or is it going to be like pioneering Americans colonizing?
Baharam, let me get you an answer, but thanks for a very interesting phone call. Even if you found nothing but piles of diamonds, it wouldn't be of much value to anybody, would it?
It would be tough to get them back from Europa. But the lander that is proposed for Europa is a robotic lander. It's not. It'll be a very long time before people are there, and I think we could probably defer that question and let the lawyers chew it over for a while.
What's the most interesting thing going on in Hubble land or astronomy in your mind that doesn't involve this particular moon?
Oh. What else is going on? Is there anything else going on?
Just a few things.
There's a lot going on in cosmology and the distant universe as a prelude to the James Webb Space Telescope, which is designed to probe the origin of the universe. And the other thing that's going on, which I think is in my world, the most interesting thing that's happening is the detection of all those planets around stars other than the Sun. Some of the stars, I mean, obviously there are near stars and distant stars, but a major goal and a really exciting goal would be to develop the technology to image and characterize planets like the Earth around other stars. So Europa, although it may host life, it's not like the Earth. As you said earlier, it's a very inhospitable place. But there are plenty of places out there that are like the Earth. And it would be fantastic if we could find ways to image them, take spectra, find out what's going on there.
And it seems to a layman like the more places you look, the more galaxies, whereas at Kepler looks for planets, the more you find.
Kepler was an incredibly successful mission. It just stared at thousands of stars, 100,000 stars in our galaxy, and found thousands of planets. And you can use that to extrapolate to the galaxy at large. And people debate the number, but it's probably going to come in between a few percent and a few tens of percents of stars, like the Sun, have planets like the Earth. And if there are billions of stars in the galaxy, then there are billions of planets in the galaxy too.
And there are billions of galaxies to look at as well.
They certainly are. And yeah.
Talk a little about the Webb. Everybody's familiar with Hubble and after its troubled start, how successful it has been. Should the Webb telescope be understood as a successor, or is it different?
It's a successor in some ways. The Hubble changed a lot of the questions that astronomers ask, and the Webb can answer some of those questions. It's an infrared telescope, not an optical telescope. But because it's so much bigger, the pictures will have a similar quality to the pictures that the Hubble takes. It can do things that the Hubble can't, though, and it can do things that telescopes from the ground can't. So, for example, as you pointed out, there's a lot of water in the Earth's atmosphere, and one of the things we'd like to know is the water elsewhere in the universe, and where is it? You can't see water looking through water, and so being up in space, being in the infrared, the James Webb has capabilities to do that, to look for interesting molecules that the Hubble can't, doesn't have the instrumentation to look for.
It's just a slightly exciting time to be in your line of work.
There are a few things going on. Yep, there's a lot going on. It's both telescopic, and there are missions in design and development beyond James Webb as well that we're already building and designing and planning. And couple that to the robotic exploration of the solar system.
Very good. William Sparks, thank you very much for your time.
Thank you.
Appreciate it. Thank you for joining us for Direct Connection. For all of us at MPT, I'm Jeff Salkin. Thanks for watching, and have a good night.
This program was made by MPT to serve all of our diverse communities.